Hello, welcome to our mini lecture on inheritance and a walkthrough of question 3. So, what is inheritance? Well, we say that a subclass inherits method signatures and final variables from a superclass. Class A extends B means that A inherits from B. So we can really quickly look at the is A relationship. So if A extends B, that means A is A B. So for example, I might have a superclass of living things. And I might have a subclass, which is a dog, right? So dog extends living things. Dog is a living thing. And maybe I might have another subclass, which is a poodle, right? Poodle extends dog. A poodle is a dog. So this is a relationship is going to be important to keep in mind, right? So right here, poodle extends dog. We can think of this diagram. Okay, how about static and dynamic types? So static types are specified during declaration. They are the things to the left of the equal sign, the type that you see to the left of the equal sign. They never change. They're checked during compilation, and you sometimes might hear them referred to as the compile time type. So if I had something like dog A is equal to whatever, this dog is the static type. Now, how about dynamic type? Well, the dynamic type is specified during instantiation, so when using the new keyword. So let's say that I have dog A is equal to new dog. Then my dog over here is going to be my dynamic type. You might also sometimes hear it referred to as the runtime type, and it's equal to the type of the object being pointed at. So how do I generally represent static and dynamic types? Well, I like to start with a box and a label on the box. The label on the box is the static type, and the thing inside the box is the dynamic type. So you can almost think of the dynamic type as being like what the object really is. Like when we start running our program, how is that object actually going to act? Well, that's going to be a question for the dynamic type. So how do we know if something is legal or not? If we're doing some sort of assignment and we have different static and dynamic types, how do we know if what we're doing is actually allowed? Well, we can use this rule of thumb right here. The dynamic type must have an is-a relationship to the static type. Otherwise, we're going to get a compile time error. Okay, so before we can get into the worksheet, I think it's good to talk about dynamic method selection. So, if we're inheriting, if we're extending, right, we might have multiple methods in different classes that we could call, right? We might have Fido1.walk, and there might be a .walk method in the dog class, but maybe Fido has a dynamic type, which is poodle, and then the poodle class also has a walk method. So we need some method in order to, or some strategy in order to figure out what method we're actually going to run. So that's what this is all about. So how does this work? Well, during compile time, we are going to jot down a placeholder method. And how are we going to do that? Well, we're going to look in the static type class for a method with signature walk. And if we find one, then we're going to jot it down. If it's not there, we'll look in the superclass, and we'll just keep doing that until we find it and jot something down. Or if no such method can be found, then we're going to say that there is a compile time error. Now at runtime is all about upgrading, essentially. If something has a static type of dog, but its dynamic type is poodle, we kind of want to upgrade and find something more representative of that dynamic type. So we want to check the dynamic type class for a method with signature walk. If it's found, we'll jot it down and use it. Otherwise, there's no upgrade possible, and we're just going to use the method that we jotted down during compile time. Okay, now we can get into question 3. I think it's called Dogs Yay. So I already started out by setting up that box and label representation that we talked about earlier, right? Well, actually, let's kind of take a look at what's going on here first. So we have a class dog, and then we have a class beagle that extends dog, okay? So a beagle is a dog, right? This is inheritance. We're seeing it right here. Now, like I said, I set up this representation over here. So the static types are the labels on the boxes, and the dynamic types are the things inside of the boxes. Okay, so let's get started with part A. So Fido1.walk. Well, what's going to happen during compile time? We're going to see that the static type of Fido1 is dog. So we're going to look in the static class, the dog class, for a walk method, and we find it. So we're just going to quickly jot down dog.walk, right? During compile time, this is what we found. And yeah, now runtime is going to come around, and we're going to look and see what's the dynamic type. Well, the dynamic type also happens to be dog, so we're going to look in the dog class again, and we're going to find that walk method, and it's just going to end up being the dog.walk method. So the dog is walking. We'll use dog.walk. Now, what about Fido2? So Fido2's static type is beagle. So we're going to jot down that beagle.walk method. And runtime is going to come around, and we're going to see that Fido2's dynamic type is a beagle. So we're going to end up going with that beagle.walk method. Now, what about Fido3? Well, remember that we talked about the relationship that needs to exist between the dynamic and static type. And here we can see that we have a violation of that is a dynamic type is a static type rule, right? Dog is a beagle. Question mark? But that's not necessarily true, right? We know that not all dogs are beagles, right? They could be poodles, they could be Yorkies, they could be anything, right? Chihuahuas. This is just not something that we can say for sure, right? So this is going to be a compile time error. Okay, what about Fido4? So let's really quickly do a check this time and see if we actually have something legal going on here. Beagle is a dog. Well, yeah, that's true, right? Beagle is a dog. So we don't have any compile time error because of that. There's nothing that's wrong with that. Okay, so now during compile time, we're going to look in the static types class and look for a walk method. So the static type is dog. So let's go up here and let's jot down that dog.walk method. Okay, now runtime is going to come around, and we're going to check and see, oh, well, Fido4's dynamic type is beagle. So let me look in the beagle class and see if I can find a method with the same exact signature. And I find one, right? I find beagle.walk. So I'm going to use that. I upgraded, right? This one, I had an upgrade. So I'm going to use that and say the beagle is walking. And that is the first part of question 3. This is a neater representation of the answers. Okay, let's do the next part. So this time we are working with the dog class, and then we have poodle, which extends dog. Okay, so poodle is a dog. Once again, this is the inheritance. We're seeing it right here. Now I've gone ahead and kind of made the representation of dog Dan and poodle. I guess that would be Pim. I'm not sure. I'm gonna say Pim. I'm not sure if that's right, but okay. So let's start off with question one. Dan dot play Dan. So let's see. What is the static type of Dan? Well, it's dog. So I'm going to look in the dog class and I'm going to try to find a method with the signature of play, but I don't even see one, right? And there's no superclass for me to look in. So this is going to be a compile time error, right? I'm just going to abbreviate it like this. And actually, I'm going to move this over because, okay. Okay, so now what about Dan.play Pim? Well, I'm gonna see that Dan's static type is dog, so I'm gonna look in the dog class and similar here, right? I don't find any play method, nothing that takes in a dog, nothing that takes in a poodle, right? It's just not there, and there's no superclass for me to check and look in. So this is, once again, this is a compile time error, okay? Now, Pim.play Dan. So Pim has a static type of poodle. So I'm going to look in the poodle class for a method with the signature play that takes in a dog. And I do find one, right? Here, I find one. So now runtime is going to come around and I'm going to look in the class that corresponds to the dynamic type, which is poodle, for something that takes in a dog. And I mean, it's the same, right? It's just this poodle class once again. So I'm going to end up here with play dog D, poodle.play that takes in a dog. This is going to be no. Now, what about pim.play Pim? So, okay, static type is poodle. Gonna look in the poodle class for something that can play with a poodle, right? Pim is a poodle. And I find it right here. Sorry, the static type of Pim is a poodle. And I find it right here, so I'm going to jot that down. Now runtime is going to come, and well, I'm still a poodle at runtime, right? Pim is still a poodle at runtime. So we're going to once again come here, find that, and we're going to output bow wow. Okay, so pim.barkdan. Well, I'm going to try to find something in the, because Pim's static type is a poodle, something in the poodle class that barks and takes in a dog, right? Because Dan's static type is a dog. And I find it right here. And similar thing, right? Runtime, it's still a poodle. It's going to find that same method signature and it's going to use it. And this is going to be woof. Now, how about for pim.barkPim? Well, I'm going to look in the poodle class for a method with signature bark that takes in a poodle, and I will find it, and it will be right here. And then during runtime, I'm going to find the same thing, and this is going to be yap. So 7 and 8. So for 7, Dan.barkDan. Okay, what is the static type of Dan? The static type of Dan is a dog. So I'm going to look in the dog class for a method with signature bark that takes in a dog. And I do find it right here. So I'm just going to jot down during compile time. I'm just going to say, okay, this is my placeholder so far. I have this. I'm just going to say that because it does take in a dog D. Okay, there. Now, during runtime, I'm going to look into the poodle subclass for a method with this exact same signature. And I find one. So I'm going to use poodle.bark that takes in a dog D during runtime. And that's going to give me woof. Now, what about Dan.bark Pim? Well, I'm going to look in the dog class for a method that is bark that takes in, I guess it could be either a poodle or a dog, right? So we find one that takes in a dog, and a dog is a poodle, so that's fine. That works. We can jot that down because a poodle is, sorry, I think I said a dog is a poodle. I meant a poodle is a dog. So now during runtime, because Dan is a poodle at runtime, I'm going to look into the poodle subclass for a method with this exact same signature. And I find one, and it's the same as what we used in number 7. So I'm going to output woof as well in number 8. So both 7 and 8 are going to output woof, and that is because of dynamic method selection. Just keep in mind that when you're doing dynamic method selection, it's really important to look for something with the exact same method signature, okay? That's really key. You're jotting down something during compile time, and you're only upgrading at runtime if you find something that has the exact same method signature, okay? So here's a nicer representation.